Hello everyone, welcome to the video. So in this lecture we are going to solve activity question 5.7 and 5.8. Okay, so we have to calculate f of g of 5. So what is g of 5? G of 5 is root over 5 plus 11, right? That is root over 16. That means f of 4. So it's 3 into 4 plus 10. And what is g of f of 5? So g of 25, that means root over 25 plus 11, that means 6. Okay. Let's move to the next question. So we have fx equals to this gx and hx given, so we have to choose the correct answer. Okay, so what is f of g of 0? This is f of 0, and that means 2 into 3, that means 6. What is g of f of 0? This is g of 6, which is 8 into 6 square. So clearly this is greater than the earlier, so this option is correct. What is h of f of 0? H of 6, that means 37. And what is f of h of 0? F of 7, that means 2 into root over 7 plus 9. So 2 into 16, that means 8. So clearly this is smaller than the other one, right? So this option is also correct. Let us now calculate f compose g. So we have this one is f and this one is g. So f compose g of x is 2 into 2, 8 x square plus 9. And g compose f of x is 8 into 2 x plus 9 square, that means 32 into x plus 9. So we can see that when x goes to there are some simple step. When x goes to infinity, then f compose g is going to infinity, right? Because x goes to infinity means x goes to minus infinity, then x square goes to infinity. So 8x square plus 9 goes to infinity, and hence f compose g goes to infinity. But if x goes to minus infinity, then x minus x plus 9 also goes to infinity. So f compose g goes to minus infinity. So clearly this is smaller than this function, right? So this option is incorrect. Now what is f compose h? So f compose h of x is f of h of x, which is 5x plus 7, and this is equals to 2 into root over 5x plus 7 plus 9, that means 2 into root over 5x plus 16, right? And what is h compose f of x? This is basically h of 2 into root over x plus 9, which is equals to 5 into 10 into root over x plus 9 plus 7. Okay, so we can write it as 2 into root over 25x plus 25 into 9 plus 7, right? So we can now compare this term and this term. Clearly 25x plus 25 into 9 is bigger than 5x plus 16. Now we can take root and multiply it with 2. So yeah, it will follow the inequality. So this function is basically greater than this function for any positive real number. So this is true. And what is h of g of 1? Let us calculate h of g of 1. So h of g of 1 is equals to h of 8 that means 5 into 8 plus 7, that means 47. And g of h of 1 is um, g of 5 plus 7, that means 12, right? So it will be 8 into 12 square. So clearly this term is greater than this term. So this option is incorrect, right? Let's now solve the next question. So we have given f and g. We have to calculate the domain of f compose g. So we know the domain of f compose g is equals to the domain of g such that range of g is subset of domain of f, right? So we have to calculate this three. So what is domain of g? Domain of g is clearly real number minus 1, right? And range of g is the whole real number, and domain of f is clearly real number minus 4. So you can see that range of g is not a subset of domain of f, so we have to extract the point, sorry, it is plus 4, so we have to extract the point plus 4 from range of g to make so that we can make the domain of the restricted domain of g as the domain of f compose g. So let's for x g of x equals to 4, okay, then 1 by x plus 1 equals to 4. From here we will get x equals to minus 3 by 4. That means if we exclude the point minus 3 by 4 from the domain of g, then we will get the range as real number minus the point 4. That means then the range will be subset of the domain of the function f, right? So the domain of f compose g will be domain of g minus 3 by 4, which is basically equals to real number minus 1 minus 3 by 4. Okay, so this is the correct answer. Let's move to the uh, next question. This is the last question. So which option is correct? If there exists x belongs to r, that is not in the domain of f, then x will not be in the domain of some composite number f compose g. So this is not true, right? Because there is no relation between domain of f and domain of f compose g. So this is not true. The domain of a composite function if compose g is set of all x such that x is in the domain of function f and fx is in the domain of a function g. This is also incorrect. So we don't have any this kind of thing. We can take some counter example also. And the statement 3 and 4 are clearly correct from the definition from the uh, concept of domain of a composite function, right? So option 3 and 4 are only correct options. Okay, thank you.